homework from last night. We'll start by going over some of the earlier problems that hopefully you didn't have too much trouble with. Okay, so problem 23. So 23, you're supposed to find the ratio. It's $161 for 7 shares. That would be like a part of a company. That's what a share means. And what you're going to do here is you're going to take the numerator and divide it by the denominator. Almost always in ratios, you have the money divided by the item. It could be the number of ounces or the number of people, but it's typically money over that other item there. And so we would get $23 per share, and this is the way that you want to write it, or you could write it like this. Either one of those two ways would be fine. Okay, so next we talk about number 29. Now, one of the weird things about 29 when you're doing a ratio is you really want to get the 1 to be in the denominator. So this is the ratio of wins to the number of games. You probably realize that that has to be less than 1 because you can't win more than games played. So again, we divide 25 by 40 and we would get 0.625 wins per game. Okay, and we would use division there. Okay, so next we move on to problem 31. In 31, they're getting you thinking about what a proportion is, and we'll talk about that more later. But hopefully you realize that 1 minute and 20 seconds were not in the same units. So the first thing I did was I changed that 1 minute to 60 seconds. Then I realized that I need to multiply the denominator by 3. If you multiply the denominator by 3, you also have to multiply the numerator by 3, which is where our question mark is 900 miles. Next, we have that problem dealing with the aquarium, problem 41. So it says an aquarium has twice as many angelfish as goldfish. That means the ratio of angel to goldfish is 2 to 1. The aquarium contains only angel and goldfish. Write a ratio for the number of goldfish to the total number of fish. So here's kind of the tricky part about this. If you have angel and goldfish, let's maybe sort of imagine this, that if we have an angelfish and an angelfish and a goldfish, so that's like a group of 3. And you can have more of these throughout the pond. And it would be the same basic thing. So then what they're asking is what's the ratio of the number of goldfish, which is the black X there, to the total number of fish. So that would be 1 to 3 or 2 to 6. So it would always work out to be 1 to 3. Okay. Great. Okay, now let's try 43 was a little bit more challenging. In this one, they're again trying to bring up your background knowledge on squares and rectangles. So they want to know the ratio of the shaded part, which is the triangle, to the non-shaded part, which would be the part up here and up here. So first, we're going to try to find the area of the triangle. And so that would be side times 1/2. If the whole area is side times side or side squared, the unshaded, if the shaded is 1/2, then the unshaded is 1/2. So the ratio of shaded to unshaded is going to be 1 to 1 because they're the same. Okay, and then the last one, we'll talk about is this stamps problem. So this is a word problem. So, and with these word problems, we really want to practice writing equations because that's one of the things that we're working on. It says you have 15 stamps from Canada in your collection. These stamps make up 3/11ths of your entire collection. So right off the bat, X equals the total collection. So 15 is, that means equals, 3/11ths of X. Now, remembering what we did in chapter 5, when we have something like this, we're going to multiply by, that's right, the reciprocal. So we multiply by the reciprocal. We simplify on the right hand side. So then we would get X equals 55. We would simplify that, and you get X equals 55. Then they say, if that's your total, how many U.S. stamps? Well, 55 is your total, and 15 are from Canada. Then that leaves 40 U.S. stamps in your collection. Okay, so let's take a little bit of time to pass that in and then maybe go over some proportion stuff. I don't know if anybody did problem 9, but 9, the key is that you again want to do the dollars divided by the total number of roses for each. Okay, so this is sort of a good example to kind of frame what types of problems we'll be doing in this chapter. If the ratio of the whole school is the same as our ratio, 9 boys to 7 girls, what's the total number of boys if there's 77 girls in the school? There are lots of different ways to solve this. One way is to set up a proportion. So if boys to girls is 9 to 7, let's change that up. Is 8 to 7. Okay, so then you just want to figure out that, so boys to girls, 8 to 7, I write it out in words. And I change this problem up here. Okay, so let's fix this. Okay, so now we're back online. We got 8 here. Okay, so how do we get from 7 to 77? We multiply by, that's right, 11. And I want to probably write that as a dot here. So times 11, if we multiply the denominator by 11, we have to also multiply the numerator by 11. So then that means that we are going to get X would equal 88 boys. Okay, so this is kind of a where proportions come into play. So let's show you an example here. I have a couple other examples similar to that. Okay, so we have a proportion. A proportion is two equal ratios. So we have a fraction and another fraction and equal sign. So the two equal ratios. What we're doing is we are setting them equal to each other. Try to ask yourself how you get from this over to here, and you would multiply by that same number. In this case, we'd multiply by, I believe it's 24. So if we multiply the denominator by 24, we have to multiply the numerator by 24. And so if we do that, we get x equals 120 and then answer the question. In this case, it would be 120 boys. You can look through these notes if you want some more practice. Here's a good example. In this one, we would multiply top and bottom by 3, which would lead x to being equal to 15. Have a great day.